You're watching a free sample video from Teacher's Test Prep. For videos like this one covering every area of your exam, visit us today at www.teacherstestprep.com.
One of the places where algebra and geometry really overlap is in the Cartesian coordinate plane. You've studied a lot about lines in your Algebra 1 class, but those same ideas connect into geometry as well. For example, we know that if two lines have the same slope, then those lines are parallel. They'll never cross. In your slide here, you see two parallel lines that are white. We have 2x plus 2 and 2x minus 1. Both of those lines have slope 2, so they never intersect. Now, perpendicular lines have what we call opposite sign reciprocal slopes. So if I wanted to start with the slope 2 and find out something that's perpendicular to that, I would do the opposite sign, like negative, and reciprocal. So instead of 2, it would be 1/2. So you see on your slide here a yellow line where we have y equals negative 1/2 x plus 4. And the negative 1/2 bit, the slope part, not the 4, but the negative 1/2, is what tells us that that yellow line is going to be perpendicular to both of the white lines. Again, parallel lines have the exact same slope. Perpendicular lines have opposite sign reciprocal slopes. You could also think about how the slopes of perpendicular lines will multiply to -1. Like for example, if I say 2/3, the perpendicular slope would be negative 3/2. Change the positive to negative and flip the fraction. We call that the reciprocal. Let's talk also about how we can connect coordinate geometry to polygons. We can use what we know about the coordinate plane to verify our conjectures about polygons, similarity, congruence, and right triangles. The distance formula will tell us that congruent segments are side lengths, and the slopes of lines can tell us if sides are perpendicular or create congruent triangles. So let's talk a little bit more about that. If we want to know if two shapes are similar, two figures are similar, that means that their corresponding side lengths are proportional. There's some growth factor or maybe a shrinking factor that I'm multiplying each side length by to get to the other side length. And if it was in the Cartesian coordinate plane, I could use the distance formula to calculate those distances and see, am I multiplying everything by the same number, like multiplying the smaller distances by 2, say, to get to the larger ones. That's how we could check similarity. Congruence, of course, is when the side lengths are the same. That's important as well. And then right angles. Oftentimes we're asked, do these 3 points create a right triangle? And one of the ways we could tell is by either finding the distances and doing the Pythagorean theorem, or finding the slopes and looking to see if any of those slopes create perpendicular lines. Now you could also look to see if you have perpendicular lines like it says in your slide using matrices and dot products, but many times just calculating the slope using the slope formula is a little bit easier. We can use coordinate geometry to do proofs. In particular, you combine your algebra skills with your geometry skills to verify a conjecture. So here we are asked to classify the quadrilateral ABCD formed by the vertices, and we have 4 points. Now this graph is already provided for you. If you were doing this problem, you'd probably want to draw a sketch, and it's okay if your sketch isn't perfect. But what you're looking for is to classify a quadrilateral. Some things you might want to consider are the distances of the side lengths. Are any of the distances the same? And you'd use the distance formula. Or the slopes. Are any of the slopes the same? That would show that you have opposite sides or some sides that are parallel. That's a key idea for parallelograms and trapezoids, those kinds of things. Another thing you might want to look at, do the slopes show that any of these angles are right angles? Again, if you have slopes that are opposite sign reciprocals, like let's say slope of 2 and negative 1/2, that would show you that you had some right angles. So let's say you were sketching these 4 vertices by hand, not necessarily on graph paper. It might look like it could be maybe a rectangle. It might look like you might have right angles in there. So what you want to do is find the slopes of all 4 of those sides using the slope formula, and you'll find that the 2 opposite sets of slopes are perpendicular. There's 2 red lines that both have slopes of negative 1/4. The 2 yellow lines both have slopes of positive 3. So the opposite sides are parallel. That way we know it's some type of parallelogram, but the slopes are not giving us right angles. They're not opposite sign reciprocals. Therefore, I know it's not like a rectangle or a square. It's just going to be a parallelogram. In isometry, or combination of isometries, is often used to transform a shape in the coordinate plane. And by transform, we mean rotate, reflect, or just shift or move. So here's an example. A coordinate rule shows a transformation. So here's an example. Every xy point is getting mapped to the x value plus 2 and the y value is minus 3. Now imagine in your head, if you have a point or a shape in the coordinate plane, if all of your x numbers become those x numbers plus 2, that's going to take your shape and move it 2 to the right, because adding 2 is a side-to-side shift to the x coordinate. We're moving it 2 to the right. and then the y value is -3. If you imagine a shape and you take all those y values and subtract 3, that shape will move down. It's called an isometry because we're not changing how big that shape is. We're not blowing it up or shrinking it. All we're doing is taking that exact same shape and shifting it over and down. It's called an isometry is. The second example says all of the coordinates x, y become opposite signs, -x and -y. And what happens is you end up reflecting the shape across both axes. First you're reflecting across the y-axis and then the x-axis, and those two put together could be called either a double reflection or just rotation 180 degrees around the origin. The last example we have here is if you're just changing the sign on one of your coordinates, like if xy gets mapped to -xy. Well, if you imagine a shape, let's say like in the first quadrant, and now all of those x values become -x values, it's going to reflect across the y-axis. It's going to go to coordinate 2, or quadrant 2. It's still going to be the same shape. It's still an isometry. We're not dilating or shrinking it. They're still congruent, but it's just we've moved it from one quadrant to the other. We can also graph shapes in a 3D coordinate plane if we add a third axis called the z-axis. And so the way we draw these usually is by starting with x and y with the right angles, we usually do, and then we have a diagonal going down to the left z-axis like you see on your slide. And so each point now doesn't just have x, y coordinates, it has x, y, and z. And we oftentimes, if we're plotting a 3D point like that, we'll draw the whole rectangular prism, the whole box that creates that. So you can see in the box how it's moving over side to side. It looks like maybe 3 units. It's moving up about 2 units, and it's coming towards us 3 units. So you could see how you would turn a point into a 3D space.
We hope you found this free Teacher's Test Prep sample video helpful. For more videos like this one covering all the subject matter and strategy you need to pass your exam, visit us today at www.teacherstestprep.com.